Hello everyone. Today we will start the nomenclature of coordination compounds. So in the nomenclature of coordination compounds, first is to write the formula of mononuclear coordination compounds. So let's write the rules pertaining to writing formula. Okay. Mononuclear means mononuclear coordination entities. Yes, tell me, what do you mean by mononuclear coordination entities? So, mononuclear means which have only a single central metal atom in the square brackets. Okay, that is called mononuclear coordination entities. So, only Ashish, Saad, Vasant, and Swati is there. What about others? So, how do we write? First of all, when we start the square bracket, the central metal atom is listed first. In the square brackets, central metal atom that is listed first. First of all, we will write the name of the central metal atom, means symbol of the central metal. It is listed first. After writing the central metal atom, we write the ligands. Okay. Yes, tell me. Okay, voice is not audible. Okay, wait. Hello. Hello. Sadh, now is it audible? Okay, beta, let me check. So see, central metal atom is listed first. Now the ligands. Okay. So ligand present are written in an alphabetical order. Okay. We will write the ligands in alphabetical order. Okay. And we will not take into account the okay beta abhi so what to do? Audible है but low है, but everything is okay there. Hello. Okay, wait, I will fix it. Hello. 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 You're right. Something is wrong here. Mm. Hello. 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 Where with it now? What to do? Okay, मैं थोड़ा जोर से बोलता हूँ. Okay. हाँ. Okay, Villa. बेटा तो ligands. First of all, we write the central metal atom that is listed first. Okay. Then we write the ligands in alphabetical order without taking into account any charge. There is no need to take into account any charge. Is it cationic, anionic, or neutral, whatever it is. Okay, that is not counted. Only alphabetical order. Okay. For example, if we have amine and aqua. Okay, so you know A same, M comes first, then Q. Okay, then first we write NH3 and then we write H2. Okay, so we will write the ligands in alphabetical order without any gap. Okay, even if they are polydentate. If polydentate ligands are there, like you know En or GLY lysine, ethylenediamine, or even oxalate. Okay, then we will take into account first letter. First letter is taken into alphabetical order. Right? Now, these metal and all the ligands are enclosed in square brackets. Okay. Now, see, these are polyatomic, so we write it in parentheses. Okay, in brackets. Okay. Now, there should be no space between the ligands and the metal. Ligand and metal, there is no space at all. Okay, and after that, if there is no counter ion, then we write the charge. Okay, if it has, let us say metal has 3 positive charge. Okay, so we write number followed by sign. See, don't write like +3. It should be number followed by sign of the charge. Okay, in the superscript we write the charge in the form first number then sign. Okay, done. Then if it is cation, then this charge is balanced by anion like Cl3, then there is no need to write the charge. Okay, if counter ions are present, then there is no need to write the charge. If there is no counter ion, then we should write the charge. Done? Okay, so this is about writing the name, the formula of the coordination compound. Done? Now naming. Now while writing the name, first of all we should know whether the complex is cationic or anionic. Cationic and neutral have the same rules. Anionic has somewhat different rules. Okay. And ligands are arranged in alphabetical order. Okay. Before the name of the central metal atom. So we should know the name of the ligands first. So first of all, naming the ligands. Let us write first anions. Chloride, bromide, cyanide, oxide. What is chloride? What is symbol of the chloride? Cl negative. And name? Name as ligand. Nowadays it is known as chlorido. Okay. Bromide, it is bromido. Okay. Now cyanide, Cn negative, it is cyano. Then oxide is oxo. Peroxide, it is peroxo. Hydroxide, OH negative, hydroxo. Sulfide, S2 negative, that is sulfido. Amide, NH2 negative, that is amido. Imide, NH2 negative, that is amido. Then nitride, that is N3 negative, that is called nitrido. Phosphide, P3 negative, that is phosphido. Okay, so these are anionic ligands: chlorido, bromido, cyano, oxo, peroxo, hydroxo, sulfido, amido, imido, nitrido, and phosphido. Okay, now carbonate. Carbonate is CO3 2 negative, and it is called carbonato. Oxalate, that is called oxalato. Nitrite, is NO2, that is NOO negative. This is called nitrite. Okay, This is called nitrito N. Then nitro. Nitro is like N. See, in nitrite, coordination is from nitrogen. Okay, sorry, nitrite coordination is from oxygen. Okay, so you see, this is called nitrito O. Okay, thank you, brother. And it is nitrito N. Okay, nitrito O means coordination is from oxygen, and nitro means nitrito N, that coordination is from nitrogen. Okay, then sulfate. Because in NO2 negative, it is nitrite as well as nitro. Okay, so if coordination is from nitrogen, that is called nitrito N. If coordination is from oxygen, that is called nitrito O. Okay, now sulfate. Sulfate is SO4 2 negative, that is sulfato. Nitrate, NO3 negative, that is called nitrato. Sulfite is SO3 2 negative, and that is called sulfito. One more, that is thiosulfate. What is thiosulfate? S2O3 2 negative, and it is named as thiosulfato. Then acetate. So acetate, CH3. Yes, beta. Sorry, chemistry with DNA means you are one of, I think you are a teacher or student. So actually there is a difference while naming, because when you write, it should be number followed by sign. That is the correct, means nomenclature, or we can say correct representation of the formula. Okay, there is always a rule to write. Okay, so it is number followed by charge, but if you write -2, sometimes, most of the time, teachers ignore it. Acetato, then thiocyanate. That is thiocyanate S, and isothiocyanate, NCS negative, that is isothiocyanato N. Thank you, beta. Thank you. Now isothiocyanato S and isothiocyanato N. neutral ligands. Like see, we have C5H5N. What is this? This is pyridine. Is represented by PY. PC6H5 thrice. That is triphenyl phosphine. O2 dioxygen, NH2 CS NH2, that is thiourea. Then NH2 CH2 CH2 NH2, ethane 1,2 diamine. If there is N2 only, that is written as dinitrogen. Then wait for some time, please. This what ethane 1,2 diamine, earlier it was known as ethylene diamine. Okay, but nowadays it is named as ethane 1,2 diamine. Keep in mind, in some books it is written as ethylene diamine. Okay, but now better to use ethane 1,2 diamine. Okay, H2O, aqua, NH3, amine, CO, carbonyl, then CS, that is thiocarbonyl, NO, that is nitrogen. Okay, then some free radicals like CH3, C2H5, C6H5, possible for you to show your video on left side of that whiteboard? Okay, yes, beta, but it is actually I'm going to set up like that only, but it will take some time. Okay, methyl, ethyl, and what about CCH5? Savan, welcome. Phenyl. Now, positive ligands. These are free radicals. Now, positive radicals. Positive ligands like NO2 positive, NO positive, NH2 NH3 positive. Yes, tell me the name of this. So NO2 positive is named as nitronium ion. Simple nitronium, okay. NO positive, nitrosonium. And what about NH2 NH3 positive? Hydrazinium. Okay. So these are the ligands. Now, if there are several ligands of the same type, then we use the prefixes di, tri, tetra, right? Penta, hexa, that you know all. And they are used to indicate the number of ligands of that type. Okay, for example, if there are 4 ammonia molecules as a ligand, then we shall write tetraamine. But note, both A, that is the last A of the tetra, and first A of amine are to be retained. You should write like, see, tetra and amine. Like in IUPAC organic nomenclature, what we do? We write tetra like this. If both are A, then one A is dropped in organic. But here, it is not like that. Both the A's are retained. Got it? Now, if in the name there is already di or tri, tetra, like say we have ethane 1,2 diamine, and we have 2 ethane 1,2 diamine, then what we do? So to avoid the confusion, what we do? We use the prefix bis instead of di. Tris for tri, tetrakis, tris for tri, tetrakis for tetra, for 4 ligands, likewise. Okay. Now, ending of the names. Now, positive and neutral have no special ending. If they are positive, means complex. If it is positive or neutral, then there is no special ending. Simply we write the name of the metal as such. But if it is anionic, it always ends with 8. And in some cases, Latin names of the certain metals are commonly used. Like if we have lead, Latin name is used. Tin. We use tin if it is cationic, but if it is different, like anionic complex, then instead of lead we use plumbate. Instead of tin we use stannate. In case of iron we use ferrite. In case of gold, what we use? We use aurate. In case of silver, we use argentate. They are very important. Keep a note of it. For copper, we use cuprate. For zinc, we use zincate. For cobalt, we use cobaltate. Okay. For platinum, we use platinate. Okay. And then oxidation state of the central metal atom or ion is generally mentioned at the end of the name with the help of numerals like 1, Roman numerals, and even 0. Okay, so let us write the name. Let us have a simple complex. Yes, this is cationic complex, Then FeCO5. This is neutral complex. K3FeCN6. This one is anionic complex. This is first one is cationic because counterions are anion. So obviously this is cationic. This is neutral, no counterion. It is neutral. This is anionic complex. So if cationic and neutral complexes are there, there is no special name given to metal. So first of all, we write the name of the ligands. Ligand is, what is the ligand? NH3. NH3 means it is amine. Okay. And how many amines? 6. For 6, it is used as hexa. Then metal, it is cobalt. So simply it is cobalt. And counterions are chloride. See, between the complex ion and the counter ion, there is an ionic bond. So there is no need to write trichloride, dichloride. It is simply written as chloride. Okay. So first of all, we write ligands. Then I will write the sequence. First we write ligands, then metal, then its oxidation number, then counter. This is the sequence. Okay, for cationic complexes. For neutral, simply ligand plus metal and oxidation number. For anionic complexes, first of all we write counterion, because counterion is before the complex. First counterion, if it is present, okay, then there is a gap, okay, space, then ligands in alphabetical order, then metal plus 8, Latin name, okay, then 8, and then oxidation. This is the order. Okay. So for first one, see, we have hexa amine, then cobalt. There is no gap at all. Oxidation number of the metal, x 0 minus 1. So it is x minus 3 equal to 0. X is plus 3. Oxidation number is plus 3. So write in Roman 3, then chloride. There should be a gap. Okay. In the space. Done. Second one. penta, carbonyl, iron 0, because CO is neutral, x plus 0 means 0. What about this? Plus 1, x minus 1. So 3 plus x minus 6 equal to 0. X minus 3 equal to 0. X equal to plus 3. So it is counter potassium, then hexacyano, no, it is ferrate. Ferrate 3. That's it. Potassium, hexacyano, ferrate 3. Any doubt? These are the 3 different names, means different naming for cationic complex, neutral complex, anionic. For cationic and neutral, same as the metal name is written. But in case of anionic complex, metal name is written in Latin and 8 is added to it. Okay. Now, sometimes we have to write point of the attachment. Like we have NH4 rice, CR, SCN6, or NH4 twice, PT, NCS 6. Okay, so let us write the name. First of all, it is ammonium counterion, then there should be a gap, and hexa SCN, so thiocyanato S chromate. And what is the oxidation number? See, x minus 1 plus 1. So 3 plus x minus 6 equal to 0. X is plus 3. So, okay. Now, ammonium x minus 1. So 2 plus x minus 6 equal to 0. X minus 4 equal to 0. X is plus 4. So again, now it is ammonium hexa. Yes, now it is, instead of, it can be written as isothiocyanato or thiocyanato N. Platinate 4. Okay, or sometimes it can be written as simply thiocyanato without S, or it is written as hexa isothiocyanato platinate 4. Done. So keep in mind, when we write ligands and metal, it should be written as a one word without any gap. And in case of ionic complexes, there should be a gap between name of the counter ion and the complex entity. And full name of non-ionic complexes should be written as a one word without any gap. Keep in mind, ligands and metal. Ligands plus metal. It should be written as a one word without any gap. So try to write the name of the compound, coordination compound, that is CO, Cl2, CO, Cl2, En twice CO. Okay, write the name of this compound. Yes, beta. Write the name of the compound. Then PT and S3 twice. Cl and NO2. Beta, write the name. Okay, methyl diamine chloro cobalt. Oh my goodness, Saad, what is it? First of all, Cl. Cl is, yes, what is Cl? It is chlorido. En is ethane 1,2 diamine. So first of all, we should write our ligands. Then CO metal, that is cobalt, and it is a cationic complex. This is cationic complex. You can note down by seeing the counter ion. Counter ion is anion, so it is a cationic complex. Okay, so its name is dichlorido. Then ethane 1,2 diamine. So di is in the ligand itself, so it is bis. Bis ethane 1,2 diamine. Cobalt. Yes, what is the oxidation number? Three. Dichlorido bis ethane 1,2 diamine. Okay, Swati, you have written second one. Okay, cobalt 3 chloride. Okay, second one. The second one is Yes. First oxidation number x 0 minus 1 minus 1. X minus 2 equal to 0. X is plus 2. Okay. And it is neutral complex. And it is diamine. It is A double M beta. What is it? Is A double M. Okay. Diamine chlorido nitrito and platinum 2. Platinum 2. Okay, very good, Swati. Diamine, Rido, Nitrito, and platinum 2 without any gap. Keep in mind, there should be no gap. It should be written as a one word. It is written as one word. Okay, no gap at all. There should be no gap. Always keep in mind. Let us write one name, means formula. We have tetramine di aqua cobalt 3 chloride. Now see, first of all we start the square bracket. CO tetramine see amine, how many amine? Tetra 4. Aqua H2O twice, bracket close, then it's 3 plus. Okay, so how many chloride? Obviously 3, so we should write it like Cl thrice. So Cl thrice. How do we find that how many chlorine are there? By looking at the charge on the complex ion. See, in this complex, ammonia is neutral, water is neutral, cobalt has plus 3 charge. So whole this complex has 3 plus charge. So 3 chlorides are required to neutralize it, to balance the charge. Okay, so counter ions are 3 because each chlorine has 1 negative charge. Okay, second one, potassium tetra cyano nickelate 2. Yes, now in this case, first of all you should write the complex. See, start the square bracket, then metal. First of all we write the metal, then ligands. How many ligands? 4. Bracket close. So what is the charge on the complex ion? Obviously 2 negative. Reason being Nickel has +2 charge, cyanide has -1. So total 4 negative, 2 plus, so 2 negative. So potassium, at 1 potassium there is 1 positive. So obviously 2 potassium are required. So what is the name? It is K2 Ni. Students have confusion most of the time that how many counter ions are there, how do we calculate? So this is the way to calculate. First of all, you should write the name of the coordination entity, coordination complex, okay, and see the charge on it and balance the charge by the counter ions. That's it. One more example, very important one. Iron 3 hexacyanoferrate 2. Tell me, in this case there are 2 iron, one is iron 3. So what is the role of this iron 3? Fe3, and other is ferrate 2, that is Fe2 plus and cyano. So see, this is counter ion, you know, because central metal ion is after ligands. Cyanide is ligand, and Fe2 plus is central metal. Okay, so first of all we should write the central metal, coordination in square bracket iron CN6. So what is the charge on this complex? Yes, answer it, reply. What is the charge on this complex? See, counter ion is Fe3 plus. What is the charge on this complex? FeCN6. What is the charge on it? Fast, beta. What is the charge on this complex? Beta, charge on it is 4 negative. See, Fe is +2. Very good, Salamas. Very good. It is 4, beta. Fe is +2. One cyanide is -1. So -6 and +2. So it is 4 negative. Simple mathematics. So it is 4 negative, it is 3 positive. So to balance it, just crisscross 4 and 3. So to crisscross, it becomes Fe4, FeCN6 thrice. So this is the formula of this particular coordination compound. Okay, this is counter ion and this is the complex ion, and as counter ion and complex ion, they form the whole this iron 3 hexacyanoferrate 2. So Fe4 and FeCN6 thrice. That is the exact formula of the given compound. Okay, so that's all for the day. We will continue the nomenclature in the next lecture. We will complete it in detail because at least one question is there of the nomenclature, or maybe two. It is of 1 mark or sometimes 2 marks. Okay, bye beta. Any doubt up to this? हाँ बेटा, बेटा iron 3 is before the ligands. Central metal is always after ligands. Central metal is after the ligands. First we write ligands and then central metal. Okay beta. Hexacyano, then ferrate. So ferrate is central metal atom or ion, but iron 3 is before this, and there is a gap between this. That means this is a counter ion. Okay beta, got it?